Okay.
Everybody's interested in learning a little bit about what comprises themselves. At the fundamental level, we know that we're made up of a bunch of molecules and enzymes. But even below that, we know that we're made up of atoms. Today I'm going to talk to you about the Higgs boson. I'm going to talk to you about how it was discovered, what it is, and why it's important. To start off, I want to talk a little bit about what our current state is. Everything is comprised of matter, and we know that all matter is made up of atoms. In our traditional model of the atom is comprised of electrons, protons, and neutrons. The protons and neutrons are what comprise the center of the atom, and the electrons are what buzz around the outside. Traditionally, we looked at the atom as a typical figure with protons and neutrons in the center, with electrons buzzing around in an orbital path. Since then, we've discovered that electrons don't necessarily just follow a path, but instead are in probability clouds, where we can't pinpoint their exact location, but we know probably where they are. We know that electrons are negatively charged, neutrons have a neutral charge, and protons have a positive charge. Now to our current understanding of the atomic structure. Since 2013, we've learned a lot about atoms. We know that the protons and neutrons are comprised of things called quarks. Quarks are up, charm, top, down, strange, and bottom. The down, strange, and bottom each have a negative 1/3 charge, and the up, charm, and top each have a 2/3 charge. This is important because it keeps the correct ratio of up, charm, and top to down, strange, and bottom are what keep protons and neutrons and electrons stable, positive, or negative. Now, currently, we use our quarks and our bosons to describe our understanding of electricity, magnetism, and gravity. We've comprised all of our calculations and equations based on these fundamental subatomic particles, but there was something missing. We didn't understand why these particles had mass or where mass came from, and that's where the Higgs boson comes in. The Higgs boson is essentially just another separate field, like there's electricity, gravity, or magnetism, and the particles that move through it have experience different levels of mass. This was first discovered by Peter Higgs in 1964. However, we didn't have the technology to discover it yet. And that's where the Large Hadron Collider in Geneva came in. The Large Hadron Collider is essentially just a big nuclear reactor where we send particles around in a giant loop and we explode them in the middle. In 2013, Higgs and his partner, Francois Inglet, won the Nobel Peace Prize for their discovery of the Higgs boson. Here is a picture of how they discovered the Higgs boson. From the explosion in the center, there was tons of remnants of the atom, but at the very center, we were able to see for a very fraction of a second, the Higgs boson. And then which was able to prove the theory of Peter Higgs correctly. This was previously called the God particle when we didn't know what it was, and the Higgs boson is a subatomic particle belonging to the Higgs field. In this next picture, you can see how the Higgs field works. Each one of these circles is a Higgs boson. Now, photons, which have no mass, don't experience the Higgs field at all. They don't collide at all with the Higgs bosons. However, the electrons and the quarks collide a lot with them, so they experience mass. With the correct number of quarks and electrons, that's what comprises all of our atoms and gives us mass today. This is another field that's a little bit more realistic of a depiction of how atoms experience the Higgs field as they move through it. Photons don't collide at all, and as a result have no mass. Whereas quarks interact heavily with the Higgs field and experience a lot of mass. Subatomic particles are called quarks, and we use these to align our studies with electricity, magnetism, and radioactivity. And overall, in conclusion, the Higgs field is a very important discovery. It was discovered by colliding atoms in the Large Hadron Collider. It's a field of subatomic particles that give other subatomic particles mass as they pass through it. And we know that this is important because all things have mass, and now we know what's at the very basis of it. Thank you for listening. Whew.